I'm good. How about you?
Good.
Nice.
So simplifying radicals and quadratics still.
Yeah.
Okay. You have any question about the distance formula?
Not really. I think it's pretty self-explanatory. Um,
Hold on a moment.
okay.
In this one right here,
Mm-hmm.
the x2 minus x1 is 8 minus 8.
Uh-huh.
But what's the y2 minus y1?
Minus 10
No,
squared, which is...
no, it's not. It's
Or,
4 minus a minus 2.
oh, I don't know why I did that then.
So
I guess I was looking at the x value and accidentally put down the
yeah,
y value.
yeah, that was just an oversight, I'm sure. So that's
Yeah.
minus 2 minus 4. So that ends up being minus 6 squared, 36.
Mm-hmm.
Square root of 36 is 6.
Okay.
So
Yeah.
the answer on that one is 6. Let me just check your work here. You got 2
Mm-hmm.
minus 3 and you got 4 minus 1. Okay, that's good.
Uh-huh.
That equals 10. Okay, square root of 10 is not 2 root 5. Let's look at that.
Okay. All
Square
right.
root of 10 is square root of 2, square root of 5, but that's not simplified. In other words,
Okay.
square root of 10 is only one term. This is two terms. So square root of 10 is simplified.
Okay.
Okay?
Right.
If it was square root of 20, then that would
Mm-hmm.
be root 4 times root 5, and that would be 2 root 5. So square root
Okay.
of 20 ends up being 2 root 5. Square root of 10 you don't ever reduce.
Okay. That makes sense.
Um,
Okay.
let's look at this one. We got, okay, you got them mixed up here.
Okay.
Make
Yeah, I
sure
was kind of confused. Like,
these are both x and these are both y.
right.
Well,
Do it
the
again.
x are 2 and minus 4.
Yeah, I don't
So
know what I was. Yeah.
it would be
No.
2 minus a minus 4, so that would be 6 squared.
Mm-hmm.
Plus the difference in the y's is 4, so that would be 16. So we would end up with the square root of 36 plus 16, which is the square root of 52. Can you simplify that?
Okay. Right. Which would be um, square root of 52. Would that be 4 and
Good. Always look to your perfect square numbers to see if there's a factor.
yeah, and 13? Yeah.
Yeah, which means it's 2 root 13.
Mm-hmm.
Okay.
Okay.
And let's go down and look at these others here.
Cool.
Root 12. That equals.
Um, okay. Um, so would that be square root of 4 and then square root of 3?
Which becomes
2 root 3.
good. About root
Okay.
50.
Um, let me think here. 2 and 25?
Yeah, it's also 10 and 5, but notice that 10 and 5 don't help, right?
No, no, not at
Anything
all.
with that. Whereas I can do something with this. What's that?
Mm-hmm. And that's going to come out to 5 root 2.
Yeah, good.
Cool. And then number 28 would be 12 and 9?
Mm,
Or no, that's
12
not
and
a...
9 aren't factors of 98.
No, it's 108.
That 9
Um,
can't be a factor of it. Those digits don't add up to 9.
No.
Any number that is divisible by 9, the digits will always add up to 9.
Right.
Okay? So
Uh-huh.
start thinking of perfect square numbers. Let's list the perfect square numbers. We got 4,
Mm-hmm.
9, 16, 25, 36. Stop me when you see something.
Okay.
Which of these numbers
36.
is a factor of 98?
36?
No?
No, that won't work. 49 would though.
Ah, right.
Cool.
Square root of 49 times square root of 2, which becomes what?
Which becomes 7 root 2.
Okay.
Cool.
And 5 root 72 becomes what?
We could do 5 root 9 and then 5 root 8.
Which becomes what?
And then that becomes, um, 5 times 3 root 8.
15 root 8. Is root 8
Yeah.
simplified?
Um, yeah, you can simplify that. 2 and then 4?
Right. In other words, it's not simplified.
No.
Okay, so that becomes 15 times root 4 times root 2. Always do it this way, and
Okay.
then pull your whole number out. Because otherwise, it's too easy to make this mistake that you made up here where you took root 10 and you got
Mm-hmm.
2 root 5. In other words, that's easy to make that mistake if you don't do it one line per step.
Okay.
So what's the final answer here?
30 root 2?
Yeah.
Cool.
Okay.
Alright.
And
And then,
7 root 28.
yeah, so that would be 7, then root 7, then root 4. And then it'd
Do the
be,
root 4 first. You see why?
or yeah, yeah, I can see why.
Because it's going to be the number you pull out. And
Okay.
my final answer is going to have a root 7 on the right
Right.
and 14 root 7.
Cool.
All right?
Alright.
6 root 75.
So it'd be 6, and then root 25, and then root 3.
Good. Which becomes,
Um, so 30 root 3.
huh?
Cool.
And now they get a little harder.
Yeah.
What's wrong with this? Why does this need changing?
You can't have a root, or a square root on the bottom of a fraction.
Yeah, you can have a square root. It just can't be an irrational square root. I
Okay.
could have a square root of 4. There's nothing wrong with this answer.
Hmm.
That's 3 halves. The
Right.
problem is you cannot have an irrational denominator. That's not
Okay.
irrational. That's rational. But any
Right.
root that does not turn into a whole number is
Hmm.
irrational, always,
Okay.
no matter what it is. In other words, root 17 is irrational.
Right.
And how do I change it so that it no longer have an irrational denominator?
Um,
Remember,
can
I
we,
can multiply any fraction, no matter what a fraction is. I can
hmm
multiply it by the number 1 without changing it.
Okay.
Okay? Well, it doesn't do any good to multiply it by 1, but what if I multiply it by square root of 2 over square root of 2, which is the number 1?
Okay.
Give me in top.
So on top would be, root 6 over,
No? It's
or,
3 root 2.
or just, yeah, and
3
then
times
over
root 2.
1.
And then what's the bottom?
Um, just 1.
2. In other words, root 2 times root 2 is 2.
Okay, that makes sense.
Root 7 times root 7 is 7. Root x times root x is x, no matter what x is.
Okay, that makes
Okay?
sense.
And notice that we now have something that has a rational denominator. It has an irrational numerator, but that's okay. There's no problem with irrational numerators.
Mm-hmm.
This process is called rationalizing the denominator.
Okay.
And what you always want to do is multiply the denominator by the same thing that it is, which means
Mm-hmm.
I have to multiply the numerator by that also.
Okay.
Okay. Next one, 12 over root 6.
Um,
Irrational again,
yeah.
denominator. So what do I want to multiply
So
this by?
root 6 over root 6.
Huh? Which gives me what?
So that gives you 12 root 6 on the top, and then
What's root 6 times root 6?
root root 36, so just 6.
Now simplify that, because I can do some simplification here.
Um, Let me see. Well,
12.
you could do,
What's 12 over 6?
oh, 2. So 2 root 6.
Root 6. Okay.
Okay.
That frequently happens when you rationalize a denominator, is you end
Uh-huh.
up with something that can then be simplified because you have that can be simplified.
Okay.
Okay. So the next one is 5 over root 8.
Alright, so we can multiply it by root 8 over root 8. And then you get 5 root 8 over 8.
And that is simplified. Can't do any
Uh-huh.
more with that.
No.
Okay.
Alright.
And
And then
the next one is, where am I at here? Lost my 35.
35.
Yeah. 8 over
Hmm.
root 12.
Yeah. Alright. And then over. Okay, so we multiply by root 12 over root 12. And then you get 8 root 12 over 12.
Can that be simplified?
No.
Hold on.
Actually, can't.
These are both even numbers. So at a very minimum, I can divide top and bottom by 2.
Uh-huh.
But I can actually divide top and bottom by 4, can I not?
Mm-hmm.
So if I
4 goes in
top
8.
by 4, I get that. If I divide the bottom by 4, I get that. In other
Yeah.
words, 8/12 is the same as 2/3.
Right.
You don't mess with the radical, but sounds like
Cool.
sounds like a Ben Stiller movie, doesn't it? You don't mess with the radical.
Exactly.
You don't mess with the Zohorn or whatever that movie was. Okay, what do I do here?
Okay, so for this one we would do, well, yeah, times it by root 5 over 5.
Root 5 over root 5.
Yeah, over root
Don't
5.
leave out your radical signs, okay? Now what's root
No.
3 times root 5?
Root 15
Okay, good.
over
And that's
5, and we
simplified.
leave it like that.
I can't simplify that anymore, and I can't simplify that. So
Nope.
yeah, don't make the mistake of thinking you can divide top and bottom by 5.
No.
You can't do that. And
Okay.
finally, this one.
Uh-huh. So we are times both, or yeah, by root 3 over root 3. So it would be 9 and then root 21 over 3. 9 divided by 3 is 3 root 21.
Very good.
Cool.
Okay, and that's how you do all of those.
Okay.
Let's apply the quadratic. Applying the quadratic formula is not hard, it's just tedious, and make sure you don't make a mistake. That's the secret.
Okay.
Okay,
Okay.
so x is equal to what?
Um, minus, or just that equation up there.
Well,
Um,
plug it in other words, what's AB? Probably the best way to do these is to start off, what's A, B, and C?
okay. So yeah, so it would be x squared.
No, it's never
Or,
the variable, it's always the
so just
coefficient,
one.
just one.
Okay.
What's B?
So a is equal to 1, b is equal to minus 5, and then c would be equal to minus 14.
Now plug in.
Okay. So it'd be x is equal to 5 plus or minus the root of minus 5 squared minus 4 times 1 times minus 14, right?
And I would always write it exactly like that.
Yeah.
And notice what, well, hold on. There's still a 2 in the bottom.
Okay.
Notice the problems that one can make here. I'm staring at 3 negative signs,
Uh-huh.
but this is a subtraction sign. The other 2 are negative signs.
Right.
If I treat them all as subtraction, I'm never going to get this right. Okay.
Mm-hmm.
So here's what I tell everybody to do. Do that separately, do that separately, so that you then have 25 minus, what's the product of these three numbers?
Minus 4 times minus 14, which is,
Not minus 4. Notice that I circled just the 4, right?
right.
Circle the minus, and I'll show you why I didn't.
Okay.
4 times minus 14 is minus 56.
Okay.
Okay? That's why I didn't. It's because now I got everything straight. That's equal
Right.
to the square root of 81.
Which is 9. Okay.
Yeah, so let's go back. But I can't emphasize this enough, that if you tried to do all of that in one step, really, really easy to make a mistake. Really
Right.
easy. So
Okay.
always do it in that part first, that part second, and then subtract the two numbers.
Okay.
Don't include that negative sign when you're calculating the product of those three numbers. You have to include
Okay.
this negative sign, but not this one back here. So what do we have now? Let's see. We have equals 5 plus or minus the square root of 81 all over 2. So
Uh-huh.
what are our two answers for x? What's the square root of 81?
9.
So now what are our
Uh,
two answers for x?
so it'd be x is equal to 45 divided by 2, which
Are
is,
you getting 45?
I did 9 times, oh, it's 9. Yeah, 9 times 5.
It's not 9 times 5. It's
Or
5
it's
plus
plus.
9 is one answer. Divided
Uh-huh.
by 2, that's 7. And the other answer is 5 minus 9 divided by 2. That's what that means. Is there's two answers. One of them uses the plus, the other uses the minus.
Okay.
Okay,
Okay.
5 minus 9 is minus 4. Divided by 2 is minus 2.
Okay.
Those are our two answers. And notice that we didn't have to use the quadratic formula here. That
No.
factors very easily. Notice how I factor it. X, signs are opposite.
Uh-huh.
Now I need factors of 14 that subtract to the number 5. Well, that's 7 and 2. I put the bigger of those factors with the sign of the middle term.
Mm,
That gives me x equals 7 or x equal minus 2.
right.
Okay? So it's almost always easier to do it by factoring.
Okay.
But this specific problem said do it using the quadratic formula. So
Mm-hmm.
that's why we did it using the quadratic. Let's do at least one more. Hold on a second.
Sure.
I somehow got these
Yeah, no problem.
out of whack. Uh,
Okay.
hold on one second. All right.
Okay.
Now this one does not factor.
No, it does not.
We can see it instantly because there's only one set of factors for the number 1. And
Right.
in a way, we're getting a middle term of 8.
Uh-huh.
So, is it helpful if I list A, B, and C, or do you need to do that? I mean, at some point, you're going to probably stop doing that.
Yeah, no, I don't think I need to.
Okay, so what's x equal
Okay, so it'd be x is equal to minus 8 and then square
to? Plus,
or plus or minus. Yeah.
you want to make sure you
Minus
have
8.
this memorized. Are they always going to write it for you or not? You're
I
ever going to
don't
have
think
to
so.
take a test where you have to have it memorized?
I believe we will. So
Okay.
I'll memorize it.
Well, when you do this, try to do it from memory and not from looking at this.
Okay.
Okay? It's really easy when you have something complicated to never memorize it if it's
Right.
always staring you in the face. I mean, if
Right.
you're always looking at this when you do these problems, I guarantee you at the end of 3 months, you will not know it.
Okay.
But if you try to memorize it, and then when in the process of using it, let's
Mm,
block it out. Now do it.
o-
And don't look
Okay.
at yours either, that on your sheet of paper on your end.
Right.
This is something I have difficulty getting students to do. In other words, it's so easy when you're doing something based on a complicated formula to just look at the formula and then go from there. The problem is your mind almost never memorizes it when you do that. Maybe after 100 times it'll sink in like osmosis,
Mm-hmm.
and sometimes it does, but the best way to memorize stuff is like using flashcards. In other words,
Okay.
make a flashcard on one side, say quadratic formula, on the other say x equals minus b, in other words, whatever it is, and then practice.
Okay.
Practice looking at one side of the card and seeing it if you know the other.
Mm-hmm.
So what is it here? So it's
All
minus
right.
b plus or minus, what's the rest of it?
I got minus 4 times 1 times minus 1.
Well, hold on. What goes
Wait, wait.
inside the radical? What goes inside the radical is the discriminant. Remember what the
Yeah, so 8
discriminant
squared.
actually
Yeah.
has its own name. That's called the discriminant.
Okay.
So we're taking the square root of the discriminant. And that's
Right.
the way to
Yeah.
memorize it. It helps if you know that this thing actually has a name all by itself. You know why it does?
Mm-mm.
Because it
No.
allows you to immediately determine whether you're going to have real solutions or imaginary ones. In other words,
Okay.
by analyzing the discriminant before doing anything, if that's negative, we're looking at the square root of a negative number. So we're
Uh-huh.
going to have imaginary solutions. If this is
Right.
positive, we're going to have real solutions. And if it's exactly equal to 0, we're only going to have one real solution, not two.
Mm-hmm.
So there's a lot to be learned by the discriminant. Number one is it makes memorizing the formula a little easier if you're familiar with the discriminant. So what's b
Okay.
squared?
So that'd be 8 squared, which is 64.
And then this is the part that even though I'm gonna write everyone out,
Mm-hmm.
See, the complicated part here is these two negative signs. People,
Right.
people are inclined to want to make this all subtraction, and it's not. In other words, some
No.
people will multiply 4 times 1 and then subtract 1 because they're looking at all these negative signs and it looks like two subtraction signs. But it's not.
Right.
What is that equal to?
So it'd be 64 minus 4, which is
See, you just made the
60.
mistake.
Oh,
That's why you do these three
that's
first.
okay.
Now we have 64 minus a minus 4. See the difference? See
Yeah.
why you want to do those three first. Because you frequently end up with minus a minus, which
Okay.
becomes square root of 68. So this whole thing becomes square root of 68. So let's see what we got here. We got minus 8 plus or minus square root of 68, which we haven't figured out yet whether we can simplify or reduce.
Mm-hmm.
Can I simplify square root of 68?
Um, Let me think.
Look at your perfect square numbers and start trying to figure out if any of these divide into 68.
Okay.
You don't have to go up very high, notice. The moment I get to 36, I know it doesn't, therefore none of the bigger ones do.
Right.
So do any of these four numbers divide into 68?
Okay. 12. No.
4 does.
Um, yeah, 4 does.
It's pretty easy to know that one doesn't. Pretty easy to
Yeah.
figure out that one doesn't. That one certainly doesn't. But 4
Mm-hmm.
does. 4 goes in there 17 times. Okay.
Okay.
So now I can write this thing minus 8 plus or minus the 4 comes out as a 2. You see where that's 2 square root 17?
Yep. Mm-hmm.
Now I can simplify it further. That's one of the beautiful things about being able to take a 2 out of there.
Uh-huh.
What's the next step?
So the next step would be, yeah, we have to divide by 2.
Divide top and bottom by 2, which means dividing both parts of the top by 2.
Okay. So it'd be minus 4 plus or minus 2 root 17.
No.
Or minus 4 plus root 17.
See why?
Yeah.
In other
Because
words,
the 2's cancel
yeah,
out.
that cancels with that, and that turns to a 4.
Okay.
Okay? So what are your two answers here?
So it'd be,
What does that mean in terms of x?
um,
For x, usually whenever you have a quadratic, you're expecting two answers, and we have two answers, but what are they? And you don't need to convert that to a decimal. You just need to state it minus 4 plus root 17.
and then minus 4 minus root 17.
That's how you do it. And that's
Okay.
the proper way to state that answer. That's the most exact way.
Okay.
If I convert this to a decimal, then I'm going to approximate an answer. If I want an exact answer, I leave it in terms of radicals.
Okay.
That's the thing about irrational numbers is they're more exact when you leave them as irrational numbers.
Right.
That's why you don't use 3.14 for pi.
Mm-hmm.
All right. Well, the half
Cool.
hour is almost up here, but let me just make sure you understand how to do some of these. Like
Sure.
40 is not in standard format. So the very first thing I have to do on 40 is bring over that 7.
Uh-huh.
Now I can apply the quadratic formula to it.
Okay.
Okay. And in 41, I got x squared. I got to bring everything over.
Uh-huh.
And I can apply the quadratic formula to that. And in 42, I got 5x squared plus 4x minus 2 equals 0, and I can apply the quadratic formula to that. But
Okay.
you can't figure out what your A, B, and C are until you get it into standard format.
Uh-huh.
Just those three formats.
Okay.
Okay?
All
All
right.
right.
Cool.
Dylan, have a good week, and I will talk to you next time.
That sounds good. All right. Thank you, Mr. Cowan.
Sure. Bye-bye.
All right. Bye-bye.